Microfibers are tiny threads, thinner than a human hair, that shed from clothing and other textiles. They're found in oceans, rivers, soil, the atmosphere, and even inside our own bodies. Gyres' previous research in collaboration with SFEI and the University of Toronto found that microfibers were pervasive across San Francisco Bay. Microfibers were found in sediment, in fish, in surface water, and stormwater, all over San Francisco. Washing clothing can release millions of microfibers into wastewater in a single load of laundry. But here's the catch. Stormwater had more microfibers than treated wastewater, an order of magnitude more microfibers, meaning that there were other sources that we hadn't fully understood and mapped yet. We asked, could dryers, especially big commercial laundromats, be a major source of microfiber pollution? To do this, we set out passive samplers, both upwind and downwind of laundromats across San Francisco Bay. Then, after 24 hours, we took these back to the lab and analyzed them under the microscope. What we found was staggering. A single laundromat can release up to 7.2 trillion microfibers in just 1 year. And across San Francisco, that could add up to more than 1 quadrillion fibers every year. They can carry toxic chemicals, infiltrate our lungs, into placentas, and even into brain tissue. When we dry our clothing, there is lint that's captured in the lint filter. We are used to cleaning these out and throwing this lint into the trash. But there are small microfibers that can escape this filter. They go through ducting and often out directly into the environment. This is all the stuff that's gone past the lint trap, going into air. Some of it's settling out on the ground. This is everything that has escaped the primary lint. It doesn't look like a lot, but a single milligram of this lint has thousands of individual microfibers that would otherwise be going into the air, into ecosystems, and into lungs. These microfibers are the most common microplastic type that we are finding in human lungs and in different parts of the body. The good news, there's a simple proven solution: filtration. The goal of our research is to test secondary dryer filters to see if these filters can capture microfibers before they're released into the air. Once these fibers are released into the environment, they're incredibly difficult to clean up. So we're trying to capture them closer to the source in a dryer. We washed synthetic fabrics, so plastic fabrics. We put these fabrics through the wash and then in a dryer. We ran normal loads, very similar to what we do when we wash our clothing at home, and saw the difference of microfibers released into the air, both with and without a filter. We built a really large box and set up a sprinkler system so we could capture all the microfibers released into the air through this sort of misting chamber, went to a really large drum. From that drum, we captured the water, filtered it out, and are individually weighing and counting microfibers to see the differences when we have a filter and when we don't have a filter. We tested several dryer filters in the lab to see if they could capture microfibers. Some filters captured over 80% of microfibers, a huge improvement. All 3 microfiber filters are commercially available and can be bought from major retailers, and might be an easy fix to capture microfibers before they're released to the environment. Right now, dryers are an overlooked source of microfiber pollution, especially in big cities. By adding better filtration and encouraging smarter textile design, we can make a real impact. It's now time for manufacturers, policymakers, and all of us to act. Want to help? Install a filtration device. Wash less and wash smarter. Support smarter policies. Learn more at 5gyres.org.